In this video, we're going to look at solving simultaneous equations using the elimination method. The whole purpose of the elimination method is to eliminate or cancel one of the variables. We do this by adding or subtracting the two equations. In order to add or subtract and how we know which one we do, we need to look at the coefficient of each of the variables. We want to make sure that both of the variables in the equations, not both of the variables, one of the variables in both equations, has the same coefficient. So you can see in this one, the y both has a coefficient of 3. So the first thing I'm going to do, as I should do with every equation, is label them. So now in this case, remember I want to cancel this variable. So if I was to add the two equations, I wouldn't get rid of it. I would end up with 6y. So what I need to do in this one is I need to subtract the two equations. Another trick to remember when you're doing questions like this is to make sure that everything is lined up nicely. So now we can almost kick at primary school a bit and use our old kind of subtraction methods. Okay, so I've got 8x minus 6x, so I'm left with 2x equals, so that's a 0. I'm going to leave it blank for now just because I'm showing you how it lines up, equals 2. Now we solve it as normal. Okay, so I'm going to divide by 2, and I've got x equals 1. Remember, I'm not done here because every coordinate has an x and a y value, so I need to solve for y now. So I'm going to sub x equals 1 into, remember it doesn't matter which one you sub it into, so long as you are calculating correctly. Okay, 3y. Sorry, I didn't show you my working. I'm going to subtract 8 from both sides. 3y equals 6, y equals 2. Once again, I'm being a little bit naughty and I'm not showing my working. I'm sorry. I always like to give my final answer as a coordinate as well. So I'll write therefore 1 and 2. Put a box around it so you know it's your final answer. In this example, you can see that this time the y's do still have the same coefficient. However, this time 1 is positive and 1 is negative. Just as a side note, it's not always going to be the y that has it. It's just happened in these examples. It could be the x that you're looking at as well. So to solve, once again, I always begin by labeling my equations. So this time, instead of subtracting the two equations, I'm going to add them together because 2 plus negative 2 equals 0. So in this case, I'm going to do equation 1 plus equation 2. Now I'm left with 7x equals 28. Solve as normal. Got x equals 4. Once again, we're only half done. Every coordinate needs an x and a y value. So sub x equals 4 into, I pretty much always just choose the first one unless the second one is a lot more simplified. But remember, it doesn't matter which one you choose. Once again, I also use brackets for my substitution so I can keep track of what I've done there. So I've got 12 equals 2. Oh, no, it doesn't. Making a lot of simple mistakes. Sorry, folks. That's what happens when you rush. Take your time. Okay, I've run out of room here. I'm going to bring this back up here so I can continue my working. Okay, now I'm going to subtract 12 from both sides. 2y equals negative 5. Divide both sides by 2. Y equals negative 5 on 2. So you can keep it like that, or if you want to, I know some people prefer decimals, y equals negative 2.5. Up to you. Finally, I always put my final answer as a coordinate. And we are done. Look at the next video for some slightly harder versions of the elimination method where neither of the coefficients are the same, so we need to do some manipulation.